All right, let's jump right in. We're going to talk about a paper that tackles a problem you've probably run into every single day, even if you didn't quite know what was going on behind the scenes.
I mean, have you ever wondered why the smartest AI on your phone can feel, well, kind of sluggish? We've got these amazing AI models, right? They understand language almost like magic. But there's a catch, a big one, and that's getting them to run fast on the actual device in your pocket.
Check out this number, 1.7 seconds. That's how long a powerhouse AI, something like the well-known BERT base model, takes to process just one piece of text on a phone like the Google Pixel 3.
And let's be real, in a world of instant taps and swipes, 1.7 seconds feels like an eternity. That kind of lag, it's a deal breaker. It makes all those cool real-time things we want on our phones, like instant grammar fixes or smart replies, pretty much impractical.
So here's what we're going to do. We're going to break down how a team of researchers cracked this speed problem. And it's a great story because the solution came from a place you would never expect. We're going to follow the clues from the world of language right into the world of computer vision.
Okay, so first things first. If you want to fix something that's slow, you got to figure out what's making it slow. You have to find the bottleneck.
And this is where it gets really interesting. When the researchers put BERT under a microscope, they found the culprit. And it was a big one. A whopping 88% of the processing time was getting eaten up by just one part of the model, the fully connected layers. That, right there, is our bottleneck.
So what do? To fix a language model, you'd think they'd look at, well, other language models. But they did something way smarter. They looked at a totally different area of AI, computer vision. Yeah, how computers see.
And this quote from the paper really hits the nail on the head. Their thinking was, hey, the computer vision folks have been wrestling with this exact same problem, making big networks run on phones for years. They've already figured out a bunch of tricks, so why reinvent the wheel?
All right, so let's get into the secret weapon they borrowed from computer vision. This is the key to the whole thing.
The technique is called a grouped convolution. I know, that sounds super technical, but honestly, the idea behind it is simple. It's basically a divide and conquer strategy for doing math.
It's like this. Imagine you have one giant, really hard math problem. Instead of giving it to one person to grind through, what if you could split it into 4 smaller, easier problems? Then you could have 4 people work on them all at the same time. You'd get the answer way, way faster, right? That's the core idea.
It's just fundamentally a more efficient way to work. You're splitting the job into parallel tracks, and that means you use just a fraction of the computing power and time. It's way better than the old brute force approach.
Okay, so now they have their secret weapon. Armed with this divide and conquer idea from computer vision, the researchers went to work and built a totally new model. Something leaner, meaner, and a whole lot faster.
And they called it SqueezeBERT. It's such a clever redesign. Think about it like this. You take the engine from a big, powerful truck. You find the heaviest, clunkiest parts, that 88% bottleneck, and you swap them out for lightweight, high-performance parts from a race car. What do? You still get all the power, but now you have incredible speed.
But that's all theory, right? The real question is, did it actually work? Did this clever little engine swap pay off in the real world? Could it be fast and still be smart? Well, let's look at the results.
And the numbers don't lie. When they tested it on a Pixel 3, the results were just crystal clear. You can see it right here. Compared to the original BERT and even another fast model called Mobile BERT, SqueezeBERT just blows them away. It's not just a bit faster, it's a lot faster. And, crucially, it's just as accurate.
The bottom line is this number, 4.3x. SqueezeBERT is over 4 times faster than the original model.
And what does that actually mean? It means that frustrating 1.7-second lag we started with, it's now just 0.4 seconds. That is the difference, the huge difference between an app that feels slow and clunky and one that feels totally instant.
So this is more than just a cool science experiment, right? This kind of breakthrough directly impacts the tech we all use every single day. It changes what's even possible to do on our phones.
And the upside here is massive. We're talking about more powerful, genuinely helpful AI that can run right on your device. Things like real-time spell check that actually works, instant spam filtering, and sentence completion that's way smarter. But here's the kicker. Because it's all happening on your phone, your data stays on your phone. It doesn't have to go to some server in the cloud, which is a huge win for privacy.
Now, of course, with any big leap forward, it's important to look at the whole picture. The authors of the paper are clear about this too. Making AI this powerful and this accessible brings new challenges. Any powerful tool can be used in different ways, and just like any AI, it's only as good as the data it was trained on. These are really important things that the whole field is working on as the tech gets better and better.
Which kind of leaves us with this really cool final thought, doesn't it? This whole breakthrough, this entire leap forward, happened because a few researchers decided to look for an answer outside of their own backyard. It makes you wonder, right? What other incredible discoveries are out there just waiting for someone to connect the dots between two completely different fields?